Great, now we're working on the second part of this equation. So first we did the first part, okay? So we use the first reactant because the question again is, what is the theoretical yield? So the first thing we did was our first reactant, magnesium hydroxide, but now we have to do the other reactant. So now for this problem, I've already done magnesium hydroxide. I'm going to cross that off so it doesn't make me confused. And we're looking for water, so I'm going to cross off this one so I don't get confused. It's just a lot to look at, so I know that I am ending here and I am starting here. So using my mole map, it is, let's see, does it give us, yep, we're in grams again, so it's going to be the exact same path. So I'm doing the exact same path as the previous problem. The only difference now is I'm using hydrochloric acid, or so they call it in this problem, yeah, hydrogen monochloride. So now I'm using I'm going to get rid of this. This is confusing to me. I'm just going to use this. And I'm going to get rid of this too. This is just for my brain. So start with my given, put it over 1 grams of HCl. Put it over 1. Next step is I'm going to have to put, according to my mole map, it says please put 1 mole of HCl, the thing I'm starting with, over grams of HCl. So I got to do a little bit of math. So work. So let's see, I've got one of them, and chlorine, I've got one of them, times, let's see, what number is this? So it's just going to be whatever hydrogen is plus whatever chlorine is. Go. So hydrogen's 1 and chlorine, where are we at? 35.45. 35.45. This one, add those together, we're going to get 36.45. Great, so that's what I'm putting in here. 36.45. Great, check that one off. I'm at my mole to mole ratio, and it says, put the mole of the new thing. It's a question mark there, right? So this question mark says we got to come up with something on our own. Mole of your new thing, which is going to be water, over the number of moles of the thing you started with, which is going to be HCl. I don't know if I'm doing these right. Let's see. I just got a little confused because I started thinking about lunch. Grams of HCl should cancel here. Grams of HCl, mole of HCl. All right, cool. So I am setting it up correctly. Putting the numbers for my balance equation in. So for water, I'm going to put that. For HCl, I'm going to put this. So you know where those are coming from. Great. Check that off. And now my last step. It says, please put grams. Okay. Question mark, which means I need to do something. Grams of my new stuff over 1 mole of my stuff. All right, instead of doing all that math again, I'm going to steal my old number, right? I've already done this math. So again, I got 18 grams. So that's what I'm going to do. I'm just going to steal it. So this problem actually doesn't take nearly as long. I'm also going to see if I can delete this stuff so I can get a nice clean answer. Sweet. Perfect. All right, let's do some math. So it's going to be 45 times 1 times 2 times 18. It's like a big number. 45 times 2 times 18 equals 1,620. Divided by, what am I getting at the bottom? 36.45. My bottom number is going to be 36.45 times 2. 72.9. Alright, so I got 1620 divided by 72.9. See where that gets me. Divided by 72.9 equals 22.22. Oops. Thanks, Miss Meyer. Equals 22.22. What's my unit? Ooh, I almost forgot my unit there. Grams of H2O. grams H2O. Alright, so now I gotta do some comparison. I have to see which number is smaller, because I have to find my limiting reactant. So if I use up all of my HCl, I make 22 grams. If I use up all of my magnesium hydroxide, I make 31 grams. Because 22 is smaller, this is going to be the reactant I have to use. This is my limiting reactant right here. It is. My limiting reactant is the one I did with this problem, right? It's HCl. Because it produced less product. It made 22 grams compared with MgOH's. What did MgOH make? 31 grams. I'm just estimating. The problem doesn't ask for this. But just so it's obvious for you. Well, I had left over MgOH, so there we go. Great. Oops, 2. And so, this whole question was, what is the theoretical yield? The most I can possibly make of this product is 22.22. So, I'm going to write it here with an arrow. Theoretical yield. And there's a chance that I made a mistake somewhere in here and all this is wrong, but the setup is correct. Cool. All right. Let's see. Let's finish out this problem. If I have 2.3 grams of dihydrogen monoxide was actually produced, what is the percent yield? Okay, so in theory, I should be able to make 22.22. And remember, this is actual over theoretical times 100. So let's replace those with actual 2.3. This seems like it's a pretty crappy experiment. So, right, because I can tell that 2.3 divided by 22.22 is going to be a pretty crummy percentage. 2.3. Yeah. Ooh, I did something wrong there. I'm going to try it again. 2.3 divided by 22.22. There we go. 10.3 times 100. 10.35%. Yuck. Not very good. 0.35%. Sweet. So there is a chance that I made a mistake in all of this. It's very, very easy to make a mistake. That this is completely wrong. However, the setup is what I'm going to be looking for. You can get this wrong. You can get this way off, and I'm going to be very generous, right? So even if every one of these is wrong, I'd say this, I probably got like a 95%. Maybe I got 100. I don't know. But anyway, this is my work and my thinking for this one. Sweet.